I really want to highlight this problem, like how the LLM trained. Like the model side is more related to the computer science community, but in this particular topic, we actually do care about how the model trained. So in current state, the model normally deal with the big data set from gigabyte to terabyte. And we also dealing with millions or even trillions, billions, trillions parameters. The model is pretty large. And also we have a limited GPU count. This is the time like people want to develop some efficient method to enable the training. So for the data side, we can break down the data into several pieces. And for the model side, we can just load into the GPU, and each GPU will dealing with a slice of the data. Once it's loaded, we can initialize the parameter. And I forgot to mention, like this demo is just a very simple case based on Microsoft methods called Deep Speed. This is a training framework to speed up and make the training very efficient on the limited quantity of GPU. Very typical, very classical method. So at the beginning stage of this training cycle, each GPU will only hold like a quarter of parameters. This makes sure the GPU can just contain like only the necessary memory and the parameter inside the memory. So at the beginning of the training cycle, the algorithm just need to broadcast the model parameter like from the first GPU to other GPU, sharing all the parameter with each other. So this actually introduced the data transfer power. After the broadcast end, then each GPU will have the parameter of the model. Then we can start this forward calculation. So we will see like in each GPU, the calculation happen. This means the calculation cost will introduce the power, like a power surge. So this will keep going like from second GPU broadcast the parameter to others, and we do this forward calculation. And then the third GPU share the parameters, and then the fourth GPU share the parameters. So at the end, then we can calculate the loss. Please notice like this loss is actually related to data slice. It's not complete. So what we're gonna do, we're gonna just do this back propagation process to just calculate the gradients of the whole model. So the parameter in the fourth GPU, we start this from the end now. So the parameters in the first GPU will start to broadcast to other GPUs. So this causes like a data transfer for sure. And then the parameter gradients will be calculated in each GPUs. And this causes like a calculation power surge. And this continue, the whole procedure will just like the reverse process of the forward path. Then it will just continue until the end. So at the end, all the GPU has this their calculated gradients, right? So what we do is to enable this optimizer to just calculate the revised parameter or the like a more accurate parameter to update the model, right? So this involves intense calculation until the end. For example, in this particular case, optimizer will give the flow point 32 revise the parameter for each GPU. This is a very intense calculation. And then it can convert to flow point 16. So this is a data type conversion. And then the model will have this revised or updated parameter. This ends the training cycle. We from this simple case, we see the LLM model. Actually, the whole training involves a lot of different stages, very complicated procedure of data transfer and the training calculation. they involve different kind of like a power level.